Magnifying power of a compound microscope. Objective: to derive the magnifying power of a compound microscope. The magnifying power m of a compound microscope is given by m equals a double dash b double dash over ab. That is, the magnifying power of a compound microscope is the ratio of the size of the final image to the size of the object. This ratio can also be represented as m equals a dash b dash over ab times a double dash b double dash over a dash b dash. That is, m equals mo times me, where mo equals a dash b dash over ab equals the magnification produced by the objective, and me equals a double dash b double dash over a dash b dash equals the magnification produced by the eyepiece. Now, if UO is the distance of the object AB from the objective, and VO is the distance of image A dash B dash from the objective, then the magnification MO equals VO over UO. In practice, object AB is placed just outside the focus of the objective, so the distance UO is nearly equal to FO. Since the focal length of an eye lens is small and the distance of the image A dash B dash from the objective is nearly equal to the length of the microscope tube, VO is nearly equal to L. Therefore, the magnification of the objective is given by MO equals L over FO. Now, since the eyepiece is acting as a simple microscope, the magnification produced by the eyepiece is given by ME equals D over FE. Using the equations for MO and ME, the total magnification of the compound microscope is given by M equals L over FO times D over FE. Here we can see that the magnification is inversely proportional to the focal length of both the lenses. Thus we can understand as to why compound microscopes use the eyepieces and objective lenses of small focal lengths. We can also say that the magnification of a compound microscope is the product of the magnifying power of the eyepiece and that of the objective lens. A compound microscope typically has a total magnification range of about 40 to 1,000 times. Modern compound microscopes are usually more complex, with multiple lens components in both objective and eyepiece assemblies. These multi-component lenses are designed to reduce various defects. The compound microscopes are generally used in laboratories to examine the thinly sliced sections of certain organic materials. Various stain slides can also be observed using a compound microscope.